Good morning, everyone. I welcome you all to the day three of Professional Development Program on AI meets Signal Processing, a practical PDP on MATLAB tools and techniques organized by Electronics and Telecommunication Department in association with IETE Student Forum, Atharva College of Engineering and Design Tech Systems Private Limited. Today's session, we will dwell into building AI application for signal processing. We will be learning about labeling, feature extractions using PCA wavelet, and also be learning about classification of ECG signal using machine learning and deep learning. At the end, we will design and run an experiment to train and compare deep learning networks using Experiment Manager app. So without further ado, let's start the session. I request our resource person, Mr. Kunal Khandelwal, sir, to please begin the session. Over to you, sir.
Thank you, ma'am. Good morning, dear participant. Ma'am has already briefed you what we'll be covering today. Okay, I have covered a detailed session on feature extraction in the last session, and I hope you might have been able to go over here and have been able to actually understand how this is being you know uh, being useful for you. Now let me just try to share my screen, and will make you understand like what we are supposed to do today. Okay, so today I will go pretty slow because we don't have much demos today. We have two demos only. One would be like how machine learning could be used for ECG signal classification, and how we can use deep learning for the signal classification. Okay, let me share my screen. Fine. Now, I have shared today's demo in the folder ECG MLDL. You can go into this folders and you can find out, okay, I have certain scripts over here, right? And whatever additional files are required, they are at the back end. Don't worry, we'll be discussing about this into detail. Okay, I have already shared the link. So let me copy this link. Right now I can see that the active users are 0. So this is indicating me that none of you have tried to click and copied it into your folder. Okay, anyways, like you can do this, or you can observe this, and later on if you feel like you want to download this or copy this into your drive, you can do that. Fine. Okay, I will delete this sharing. Okay, I will disable this link, and probably I will also delete this folder later on after 1 week. Since you can see that I have a space of 20 GB. All of you who have MATLAB CW license has a capacity to store the data set and the demo files, and the storage capacity is up to 20 GB. After this, I have to delete certain files. Okay, anyways, there is one more thing. I've already shared you the modular curriculum, right? Now, if you go to modular curriculum, inside the modular curriculum, there are courses, AI/ML course. You can go to this course. All the modules which are required are present over here. You can see there are modules. right? Okay, all the modules are there. So this is one course related to AIML. Another course you will find out over here is this deep learning and computer vision workshop. We will take this, we'll try to see, okay, later on when we'll deep dive with images and videos. Okay. So this is another course, image processing fundamentals. All the codes are given over here. You can refer to this. And there are many other courses also. Share the entire modular course where with you so that you should be able to take any course and use it into your workflow. You will also find out few courses with respect to robotic manipulators over here. Okay. You may also find out over here quadcopter modeling, if you can see, which is a quadcopter modeling over here, right? Okay. Mobile robotics course for maths, IoT, and other things. Anyways, let us try to start with the session. Okay. Fine. Let me begin. Yesterday, we have discussed that how audio signals can make use of CNN, right? I will try to repeat this part and then, we will try and perform demo for machine learning using classification learner, and then we'll come back to this again. So what is the first step? The first step is to get the audio, that is acquire the data, acquire the signal, and you label the signal. What is number two? You go and have an audio data store. If there are images, you will go for image data store. Next, you will split up the data, right? You will augment the data based upon the neural network that you're using. So if you look at the above part, this could be divided into two parts. So you can see, okay, these are two different architectures. These are two different architectures. So in the first one, we are directly passing on the raw data and some features extraction, and we can go ahead, right? Now, if we try to compare the two models, here you can see we take signals, we transform this. So here we are talking about time frequency representation, and we have seen that you can use kilogram as well as spectrograms. Okay, so here when you go for time frequency representation, this becomes image, and when you have images, you can go for convolutional neural network. Fine. But if I do not represent the signals and labels in time frequency format, what I can do? See, in that case, what you can do is you can represent this raw signal into a table. So this table will be a feature extraction table. So this is a table. What this table will consist of: column 1 will be feature 1, feature 2, feature 3. And at last you will find out over here, I will have my label L, right? Okay. So what it would be? It would be feature 1, it would be feature 2, feature 3, and so on. And what would be these features? So these features either would be derived from statistical background, that would be mean, median, average, moving average, standard deviation, variance, etc. So you can have sample 1, you can have all those features, and you can say that signal is a normal signal. Heartbeat is normal. Next, this would be abnormal. I'm writing AN over here. So likewise, I can prepare my table. And when you have a tabular data like this, we have approach. The approaches are either you can go ahead and use machine learning, okay? Or here I can use LSTM network, long short-term memory. Don't worry, I am not going into detail. I will also try to refrain myself from, actually asking you to do a demo for LSTM, a hands-on demo session for a LSTM learning, right? I hope most of you have already covered uh, the yesterday's concept when you would have completed that on-ramp course, right? Okay. Shall we move ahead then? Any doubts? Anything you want me to anything you want me to ask? Okay. So this is what we'll be doing today. We have covered certain fundamentals. Okay. We will be learning the deep learning fundamentals with respect to the ECG signal. We'll also learn the fundamental of machine learning. And here the data set which I'm taking, okay, it's a data set from a particular data set challenge, a competition, right? I'll also show you that. Fine. Just a small recap for you all. We have seen the definitions of AI, machine learning, and deep learning. Okay. So in machine learning, what we have done, that machine learning may be divided into two types: supervised machine learning and unsupervised machine learning. In supervised machine learning, we discussed that the model accepts both input and output. And the task could be the task of classification, or it could be a regression. In unsupervised learning, okay, so when you go to classification and you think of, I want to classify into red, blue, or green. So what you can do is you can use logistic regression model. You can use SVM model. When you come to regression, where you want to predict a number, a numeric value, you can say, okay, I can use, okay, linear regression, something like that. And when you come to unsupervised learning, where we apply only the input data to the model will try to learn the internal representation, the patterns in the data, and will try to cluster them. Okay, fine. Here, someone can think of using an algorithm like k-means clustering. I have already discussed this example. Like for regression, the task could be, compute the day ahead system load forecast, or it could be like, okay, depending upon the monsoon pattern, how much rainfall is expected. And based upon that, how you can classify it to be yellow alert, orange alert, and red alert. Okay, interesting. Let me put it into different way now. So yellow alert. Right? Most of the time when there is a monsoon season, you may often hear that the Indian Institute of Tropical Management, that is IITM, and IMD, Institute of Meteorological Department, they will try to issue a warning to the fishermen, those who go inside sea. Okay. It will also issue a notice to the people who stay near seashore, and they will say, okay, it is expected that there will be, high tide, and high tide can be of 2 meters or 5 meters. Think of that, how the data would have been captured using sensors. The model is to be built up, and accordingly, what you can say, you can go and have like this. I have discussed the example of classification, wherein you have sensors and you are supposed to classify depending upon the physical activity is being at present, undertaken by a human being. Next, clustering.